This video will go over how to determine the equation of a line, as well as various linear models. One formula that's really useful in helping us determine the equation of a line is something we call the point-slope formula. Right. Here's the nice, neat formula for point-slope form. We get this formula because if you take the formula for the slope of a line, and this is consisting of the points x, y, and x1, y1, which are on the graph of a line. Now if you multiply both sides by x minus x1, those cancel out, so you have y minus y1 equals m times x minus x1. That's how we get it. Here's an example. Write an equation of the line that passes through this point and has this slope. Well, if we remember the point-slope form of a line, y minus y1 equals the slope times x minus x1. And if we plug in our values, our x and y values for this point into x1 and y1, and this value in for our slope, we'd have y minus the y coordinate, which is 1, equals the slope, which is negative 3, times x minus negative 4. And so now, remember in the parentheses, since you have an x minus negative 4, those both turn into addition, so you have negative 3 times x plus 4 equals y minus 1. Now, if you distribute, you have negative 3x, negative 3 times positive 4, which would be minus 12, equals y minus 1. Now if you add 1 to both sides to get the y by itself, that gives you y equals negative 3x and then minus 11. Right, here's an example I want you to try on your own. Find the equation of the line that passes through this point, negative 4, 3, and has a slope of 3/4. Right, you can start off by plugging it into your point-slope formula. Right, plug in your y value, which is 3, so y minus 3 equals the slope, which is 3/4, times x minus negative 4. Now, see how we're subtracting a negative 4 inside the parentheses? Since we're subtracting a negative, that would change into addition. So now if we distribute, you have 3/4 x, and 3/4 times 4 would just give you 3. And if you're confused about how, you have 3/4 times 4. If we're multiplying, the 4's cancel out. Because remember, this 4 is like having 4 over 1, because 4 over 1 just gives you 4. So the 4's cancel out, so you just have 1's on top, so 3 times 1 is 3 over 1 times 1, which is 1. 3 over 1 gives you 3, so that's why it's 3. And then you have y minus 3. So if you add 3 to both sides, so y is equal to 3/4 x and then plus 6. Right. So write an equation of the line through negative 3, 2 and 2, negative 4. Write the result in standard form, ax plus by equals c. Remember a, b, and c are from the set of integers, and a, for the sake of following what your textbook teaches, I'm going to make sure that the number in front of x is always greater than 0. actually greater than or equal to 0. So, in order to figure out the equation of a line, we need the slope. So it'd be m equals, subtract the y coordinates, so 2. If we can start with this first point here, so we could do 2 minus negative 4 for the y's. Then for the x coordinates, you have to start with the same point, so it'd be negative 3 minus 2. So 2 minus negative 4 would be positive 6, negative 3 minus 2 would be negative 5. So the slope is negative 6/5. Now you can do the point slope formula. You could choose either of those points you want. I'm going to choose the second one. So it's going to be y minus the y coordinate, which would be negative 4, equals the slope, which is negative 6/5, and then x minus 2. So now, on the left hand side we have y minus negative 4. That's the same as saying y plus 4 equals, then you have negative 6/5 times x minus 2. If we distribute, we have negative 6 over 5 times x, and then negative 6/5 times negative 2. Since we have a negative times a negative, that would be addition. That would turn into addition, then 6/5 times 2, that would be 12/5. Now if you notice, both fractions have a denominator of 5, so we're going to multiply both the top and the bottom by 5. So that would be 5 times y, which is 5y, plus 4 times 5, which is 20, equals negative 6/5 times 5. The 5's would cancel out, so you'd have minus 6x, and then the 5's cancel out here, so you'd have plus 12. So now, let's get the x and y's on the same side. If you add 6x to both sides, and also let's get the constant on the other side, so if we subtract 20, then this 20 and this minus 20 would cancel out, and this minus 6 and plus 6x would cancel out. So you have positive 6x, or just 6x, and then positive 5y, or plus 5y, equals 12 minus 20, which would be negative 8. So now here's a similar problem. Find the equation of the line that goes through these points, and let's put it in standard form like in before. Alright, our slope was just subtract the y coordinate, so if you were to do 4 minus 3, start with this point. Then whenever we subtract the x coordinates, it would be 3 minus, and this x coordinate, which would be minus 1. 4 minus 3 is 1. 3 minus negative 1 would be 3 plus 1, which is 4, so the slope is 1/4. So, if you subtract the y coordinates, pick one point and then plug it into our point slope formula. So if you subtract the y coordinate, that'd be y minus 4 equals the slope of 1/4, and times x minus the x coordinate of 3. Now if you distribute, you have 1/4 x, and then 1/4 times minus 3, which would be minus 3/4, and then y minus 4. So now, if you notice on the right hand side, both fractions have a denominator of 4, so why don't we multiply everything by 4? Get rid of the fractions. The 4's cancel out, so on the right hand side you're left with just 1 times x, or 1x, or just x, and then minus 3. Since the 4's canceled out, you're just left with x minus 3. And on the left hand side you have y times 4, or 4y, minus, and then 4 times 4 gives you 16. So now, let's subtract 4y from both sides, and then add 3 to both sides, because we want to cancel out the 4 y's over here and then the plus and minus 3's over here. So you have negative 16 plus 3 is minus 13 equals x minus 4y. But if you want to remember, this can also be rewritten as just x minus 4y equals negative 13. Now the next equation of a line we're going to go over is something we call the... Alright, here's an example. It says find the slope and y-intercept of the line with the equation 4x plus 5y equals negative 10. Alright, in order to do that, or one way to do that is by getting it into slope-intercept form. So if we subtract 4x by itself, that cancels out, so on the left-hand side we're left with 5y equals, and then negative 4x minus 10. So now to solve for y, if we divide everything by 5, those cancel out, so you're left with y equals negative 4 over 5, so it would be negative 4/5 x, and then negative 10 over 5, which would be minus 2. So our slope is negative 4/5, because remember it's the number in front of x, and our b is 2. Okay, so here's an example I want you to try on your own. Determine the slope and y-intercept of this problem. X plus 3y equals negative 9. Alright, to figure that out we need to get into slope-intercept form, so let's start by getting the 3y by itself. If we subtract x from both sides, we would have 3y equals minus x and then minus 9. Now if we divide everything by 3, we have y equals negative x over 3, which would be, remember this negative x, that's the same as having negative 1 times x. So now that's like having negative 1 divided by 3, which would be negative 1/3 x, and then minus 9 over 3, which would be minus 3. Wait, that's not our answer. It's asking for the slope and y-intercept. So our slope is negative 1/3, and our b is negative 3. Slope's the number in front of x, the y-intercept is the number being added or subtracted on the end. So here's another example I want you to try on your own, or at least the first part of it. Write an equation of the line that goes through the points 1, 1, and 2, 4. Right. To do that, we first need the slope. So it'd be 4 minus 1, which is 3. And then subtract the x-coordinate, so 2 minus 1, which is 1. So our slope is positive 3. We're going to do the equation of the line in slope-intercept form. So let's use our point-slope formula. So it'd be y minus, let's do the first point, 1 equals 3 times x minus 1. And if you had chosen the other point, 2, 4, that's perfectly fine. You should get the same answer either way. So now, if you distribute, that'd be 3 times x, which is 3x, and then 3 times minus 1, which is minus 3. And then y minus 1. So if you add 1 now, you have y equals 3x and then minus 2. Alright, here's an explanation of how you would graph it. You start at negative 2 on the y-axis, because that's your y-intercept, which is minus 2. And then you go up 3, because the slope is positive 3, and then right 1. Just remember, the slope was 3 over 1, or 3, so it'd be up 3 in the positive y direction, right 1 in the positive x direction. And then once you plot 2 points on the graph, you can just draw a line that goes through those 2 points and keeps on going. Here's another example. It says, use the graph of the linear function shown in figure 45 to complete the following. says find the slope, the y-intercept, and the x-intercept. Also, write the equation that defines f. So for part A, the slope. Alright, you have 2 points right here. Right, I mean it's right here. So if you count up and over, you notice that's 1 unit up, so that's 1 in the positive y direction. Then you go 1, 2, 3 units to the left, so that'd be minus 3 in the x direction. So our slope would be the y displacement, which is positive 1, divided by the x displacement, which is negative 3, so our slope is negative 1/3. And our y-intercept, since it crosses the y-axis at negative 1, the coordinates would be 0 for the x, and then negative 1 for the y. For the x-intercept, it crosses the x-axis at negative 3, so since it crosses the x-axis at negative 3, it'd be at the point negative 3, 0. And for B, write the equation that defines f. So you could say y equals or f of x equals, it doesn't matter. Remember, you take the slope, which is negative 1/3, put it in front of x, so negative 1/3 x, and then put the y-intercept on the end. Remember, it's y equals mx plus b, or f of x equals mx plus b. So the slope times x, and then plus the y-intercept. Now our y-intercept is negative 1, so we can just do negative 1/3 x minus 1. Alright, here's another graph. I want you to do the exact same thing. Give me the slope, the x-intercept, the y-intercept, and the equation. So, to figure out the slope, you have to count how many units up and over from one point to the next. So if we notice, if we go from the x-intercept of 3, 0, which would be right here, so write that in for your x-intercept. If you notice, you have your y-intercept here of 0 from 4. So we can go ahead and put that for our y-intercept. Let's figure out our slope. Alright, we have to go 1, 2, 3, 4 units up. To go from 0 to 4, and then you have to go 1, 2, 3 units to go from one point to the next. Now the y displacement, since we went upward, that would be in the positive y direction, so it would be positive 4. But whenever we went in the x direction, we were going left, which would say negative direction, so it would be negative 3. So our slope is 4 over negative 3, or negative 4/3. And our equation, so it would be y minus, I like using zeros, honestly. So it would be y minus 0 equals negative 4/3, and then x minus 3. Alright, so y minus 0 is y. Negative 4/3 times x is negative 4/3 x. Negative 4/3 times negative 3 would be plus 4. One thing I briefly want to touch on is the concept of horizontal and vertical lines. Alright, so equations of vertical and horizontal lines. A vertical line that passes through a point, since it's vertical, it goes through the x-axis, so it'd be x equals whatever the x-coordinate of the point is. And for the horizontal line that goes through the point, since it's horizontal, it would be going through the y-axis, so it'd be y equals the y-coordinate. Just so you know, a horizontal line has a slope of 0, and a vertical line has a slope that is undefined. Next thing we're going to go over is the concept of parallel and perpendicular lines. Alright, when two lines are parallel if they have the same slope. Remember, perpendicular lines, what you need to remember about this is that the slopes of perpendicular lines are negative reciprocals. Meaning that the slope of one line is, say, positive 2/3, the slope of the other line would be negative 3/2. And the slope of one line was like negative 1/4. The slope of the other line would be positive 4/1, which would just be positive 4. That's what it means by negative reciprocals. And opposite reciprocals, if you multiply them together, have a product of negative 1. Alright, remember, slope-intercept form is the y equals, so y equals mx plus b. And standard form is when you have the x and y terms on the same side and the constant on the other. So for before we even start working part A, since we're dealing with the same linear equation, why don't we get this into slope-intercept form so we can figure out the slope. Alright, so 2x plus 5y equals 4. Now if you subtract 2x from both sides, you have 5y equals negative 2x plus 4. Then divide by 5. You'll find that that equation is y equals negative 2/5 x plus 4/5. So the slope of this line in both A and B is negative 2/5. So for part A, to find out if it's parallel, we want it to have the same slope, so we're going to use a slope of negative 2/5. And we're going to start by getting the line in slope-intercept form. So y equals negative 2/5 x. I'm going to show you a different way to figure out the y-intercept besides using the point-slope formula. There's another method so you don't always have to use the point-slope formula, and I'm going to use this example to show you. Alright, we know the line contains the point 3, 5. We know that's the x-coordinate and that's the y-coordinate. So if we actually plug this in, plug 5 in for y, plug 3 in for x, and then if we solve for b, that would give us our y-intercept. So this means that 5 is equal to negative 2/5 times 3, which would be negative 6/5, plus b. So if you add 6/5 to both sides, if you want to come up here, b is equal to 5 plus 6/5. Remember, 5 can be rewritten as 25 over 5 plus 6/5. And then 25 plus 6 would be 31 over 5. So our equation in slope-intercept form would be negative 2/5 x plus 31 over 5. Now to get it into standard form, we take our equation and see how both the fractions have a denominator of 5. Whenever we're talking about standard form, we don't like having fractions. So if we multiply everything by 5, those 5's will cancel out on the right hand side, so you just have minus 2x plus 31, and then you have y times 5, or 5y. Now if you add 2x to both sides, you'd have 2x plus 5y equals 31. So for now, part B, we want the slope of a line that's perpendicular to that contains the point 3,5. If the slope of our original line was negative 2/5, that means that we would use a slope of, since our original slope was negative, we would use positive 5/2. So, we can use the same method we used in part A to find the equation of our line in slope-intercept form. 5/2 x plus whatever the y-intercept is. And I believe we were told it contains the point 3,5. So if we plug these values in, plug 5 in for y, 3 in for x. So 5/2 times 3 would be 15/2 times 5, or equals 5, and then plus b. So if you subtract 15/2 from both sides, bring it up here, you have, after those cancel out, b equals 5 minus 15/2. Remember, 5 can be rewritten as 10/2 minus 15/2. So that would be minus 5/2. So our equation is 5/2 x minus 5/2. That's the equation of the line in slope-intercept form. Now, to figure out the equation of the line in standard form, you take the slope-intercept form, multiply everything by 2 because the denominator is 2. So you're left with 2y equals 5x minus 5, because the 2's would cancel out on the right hand side. Now I believe we said that we're going to keep it like the book and keep the x term positive. So if you subtract 2y from both sides and add 5, the 2y and the minus 2y would cancel out, so you would have 5 equals, those would cancel out, so you'd have 5x minus 2y. Alright, here's another example of finding the equation of a line. Find the equation of the line that goes through this point 1,6 and is perpendicular to 3x plus 5y equals 1. Alright. So, I'd recommend starting off by finding the slope of this line, get it into y equals, get into slope-intercept form. Subtract 3x from both sides. So 5y equals negative 3x plus 1. Divide by 5. So y equals negative 3/5 x plus 1. Now our slope in our line is negative 3/5, but we want the slope that's perpendicular, so we would use a slope of positive 5/3. So we'd use this slope and this point to find the equation. And let's do it using the point-slope formula, just because I do want to practice using both methods to find the equation of a line. Alright, so we have this equation. So y, it's not y equals, it'd be y minus the y-coordinate of 6 equals the slope of 5/3 times x minus 1. So now if we distribute, it'd be y minus 6 equals 5/3 x minus 5/3. Here's 5/3 times x is 5x, 5/3 times minus 1 would be minus 5/3. So now if we add 6 to both sides, we would have 5/3 x, then negative 5/3 plus 6. If we're adding 6, that's the same as having 18 over 3. So negative 5 plus 18 would be positive 13 over 3. That's the equation in slope-intercept form. Now, you may be asked to give the equation in both slope-intercept form and in standard form. If you're asked to also give it in standard form, here's what you would do. You would take your equation in slope-intercept form, 5/3 x plus 13 over 3, multiply by 3, get rid of the fractions. That's why we multiply by 3, is because both fractions have a denominator of 3. So you have 3y equals 5x plus 13. Subtract 3y. Get the x and y's on the same side, that's why we're doing this. And we want the constant on the other side, so that's why we're going to subtract 13. So we have negative 13 equals 5x minus 3y. If you want to be really particular, you could write it as 5x minus 3y equals negative 13. Just flip which side the equal sign they're on. But you could just leave it like this. Both ways work. Alright, so here's a 3-part problem. It gives you a table of values, and you're told that it does represent a linear function. First question is to find the slope defined by this linear function. Okay, so for part A, remember, slope is just the change in y over the change in x, delta y over delta x. So if you notice, each x value as you go down is changing by positive 1. So you could write positive 1 for the change in x, and for the y values, if you notice, they're all changing by 3. From negative 11 to negative 8 is changing by positive 3. From negative 8 to negative 5 is positive 3. From negative 5 to negative 2 is positive 3. From negative 2 to positive 1 is positive 3. And from 1 to 4 is once again positive 3. So that means the change in y is positive 3. So that means our slope is 3. Now the y-intercept. Let me erase this stuff from the table so it'll be easier to read. Remember, our y-intercept is of the form 0 and then some number for the y-coordinate. So our y-intercept has a 0 for the x-coordinate, and if you notice, that would be right here. So our y-intercept is the point 0, negative 5. So the equation in slope-intercept form would be y equals mx plus b, normally, because that's what we're used to seeing. That's what we mean by slope-intercept form. And our slope, we said, was positive 3. And our y-intercept, we said, was negative 5. So it would be negative. So the equation slope-intercept form would be y equals 3x minus 5.